Hello everyone, myself Dr. Siddharth Reddy, Associate Professor of Chemistry, Vardhaman College of Engineering, Hyderabad. In this video, I am going to discuss about secondary batteries. The secondary batteries will take the example of lead acid storage battery. As we know that any battery which consists of anode, cathode and next one electrolytic solution is present. In this case, in the lead acid storage battery, in the construction of the lead acid storage battery, lead plates which will be used as a anode, lead oxide plates which will be act as a cathode, and 20% of sulfuric acid which will be act as a electrolytic solution. If we take the construction in this particular battery, as we know that two or more electrochemical cells combined in the series is defined as battery, right? Here in this case we are taking 6 cells are mounted side by side. 6 cells means it consists of 12 electrodes. Out of 12 electrodes, 6 anodes are present and 6 cathodes are present. Anodes and cathodes are arranged alternatively to each other in the construction of this particular battery. And the cell voltage, we are taking that 6 cells, right? That each cell voltage, if we consider, the cell voltage is 2 volts, nothing but. If we take 6 cells are combined in the series, the cell voltage, or we can take that the battery voltage is 12 volts we can consider. And as we discussed that lead plates and lead oxide plates are alternatively arranged in the construction. And this is the diagrammatical representation of lead acid storage battery. Here we are taking the lead plates are present which will be act as what? Anode. And how they are arranged here, blue color one, that all represent the anode which are alternatively arranged, and red color represents the cathode, that is lead oxide plates, which also alternatively arranged to the top what? Lead plates. The meaning is lead and lead oxide plate alternatively arranged in the construction of this battery, and these lead and lead oxide plates will be placed in the sulfuric acid, that is 20% of sulfuric acid, which acts as a electrolytic solution. Now you are observing this one, this we can understand based on this, we can understand it is very clear that how the anode is placed, how the cathode is placed, how the reaction will be takes place, that we can understand based on this diagrammatical representation. If it move to the working, how the working of this particular battery takes place. Working means generally we should consider the reaction spot. In the reaction spot, mainly as we know that this is a secondary battery, we can consider both discharging reactions and as well as charging reactions. Why? Because we know that any secondary battery we can consider reactants, if we take it should be converted into the products that we can consider as discharging, and whenever we are taking the reverse of this reaction, nothing but products should be converted into reactants that will be considered as what? Charging reactions. First of all, let us discuss the discharging reactions. Let us discuss the discharging reactions. Discharging reaction means first we need to understand the reaction which takes place at anode, right? Let us consider that as in the construction we have discussed, lead will be act as a anode and where oxidation reaction takes place. Then what is the oxidation reaction? Oxidation reaction nothing but we know that loss of electrons. Now we can understand what is oxidation reaction takes place at lead during the discharging. The reaction is Pb gives rise to Pb plus 2 electrons. And the released Pb plus 2 ions straight away combines with sulfate ions and gives rise to PbSO4. And the net reaction which takes place at anode during the discharging is the common terms which are present on the left side and right side will be cancelled. Then therefore the reaction is Pb plus SO4 minus 2 gives rise to PbSO4 plus 2 electrons. This is the reaction which takes place at anode. Now we should understand that what is the reaction which takes place at cathode during the discharging of the battery. As we know that lead oxide plates which we have taken as a cathode in the construction, and where which reaction takes place here? A reduction reaction takes place. We know that reduction meaning is what? Gaining of electrons. Now let us concentrate the reactions which takes place at cathode or PbO2. As we taken that which will be act as a cathode, it combines with the H plus ions from the electrolytic solution. It takes the electrons which are released at anode and gives rise to Pb plus 2 and water will be released. And we have to balance the equation. We have to take 4H plus, and we know that 2 electrons are released and 2 electrons will be involved in the cathodic reaction, Pb plus 2, and we know that 4, and this should be taken as 2. Now the reaction is balanced. Now this released Pb plus 2 is here, right? This Pb plus 2 combines with sulfate ion, gives rise to PbSO4. Now we observe that what is the net reaction takes place at cathode. Pb plus 2 get cancelled, then we need to write that PbO2 plus 4H plus SO4 minus 2 plus 2 electrons gives rise to PbSO4 plus 2H2. PbSO4 plus 2H2, and this is a reaction which takes place at cathode. Now we need to understand what is the overall reaction, or else we can call it as what is the net reaction which takes place during the discharging. Net reaction or overall reaction meaning is what? The combination of what? This anodic reaction and as well as cathodic reaction. And what are the common terms are there which will be get cancelled? The two electrons will be get cancelled. Any common terms are there on both sides? So yeah, no common terms are there. Then we can write what is the net reaction here, and left side which are present Pb plus PbO2 plus 4H plus here SO4 minus 2 is present, here SO4 minus 2, nothing but 2 SO4 minus 2 gives rise to here PbSO4, here PbSO4, 2 PbSO4 plus 2H2O, 2PbSO4 plus 2H2O, and 4H plus 2SO4 minus 2, nothing but combination we can write it as what? 2H2SO4 plus here, as we know that it is a discharging reaction, energy should be released, and this is a net reaction we can understand which takes place during the discharging of the lead acid storage battery. Nothing but now we are taking that these are the reactants and these are the products. Reactants convert into the products, we can consider it as what? Discharging. Now let us try to understand what are the charging reactions during the working of this particular battery here. As we know that product should be converted into reactant, right? That meaning is simply we can understand the charging reactions that the reaction which takes place during the discharging will be reversed. In each case it will be reversed, like anode, this reaction should be right in the reverse direction. Similarly, the reaction which takes place at cathode, that should also write in the reverse direction. Let us discuss how the reaction takes place. Let us consider this reaction. If we write the reverse of that, gives, that is PbSO4 plus 2 electrons gives rise to Pb plus SO4 minus 2. Now you are observing one important thing here, the 2 electrons which are present on the left side, right? Left side means what? That reaction which takes place at what? The reaction which takes place at what? Cathode. As we know that it is a gaining of electrons. Let us consider the reverse of this reaction here. And what is the reaction here? PbSO4 plus 2H2O gives rise to PbO2 plus 4H plus SO4 minus 2 plus 2 electrons. Here 2 electrons are released, therefore this reaction generally takes place at what? Anode. And now we should write the net reaction, which is a combination of cathodic reaction and anodic reaction. The common terms what we are taking will be cancelled. Net reaction is 2 PbSO4 plus 2H2O plus energy, that employs Pb plus PbO2 plus 2H2SO4, and this is a net reaction which takes place during the charging of the battery here. And now you compare discharging net reaction and charging reaction, both should be reversed. Then we take the advantages. First one, the first advantage is it should be act as both voltaic cell and electrolytic cell. As we know that the meaning of voltaic cell nothing but it is also called electrochemical cell. Electrochemical cell nothing but which converts the chemical energy into electrical energy. And it also acts as electrolytic cell, right? Reverse of the electrochemicals, nothing but which converts the electrical energy into chemical energy. As the interesting thing here, it should be act as both voltaic and as well as electrochemical cell. That majorly we are using in the electric vehicles, electric cars we are using. Second advantage is the cell voltage is 12 volts, but even though it is a constant potential, every time it is giving the 12 volts. As earlier we have discussed, right, it consists of 6 cells and each cell it is giving what, 2 volts, and the battery, the cell voltage, battery voltage is output, the 12 volts will be released. And the important thing, important advantage is what, it is portable and cheap. These are the advantages of lead acid storage battery. Next we will move to the applications. Where we are using, generally the major applications which we are using these particular lead acid storage batteries are electric vehicles, right? Nowadays the trend is there, right? Everywhere we are observing on the roads, we are observing the electric vehicles. And also we can use in the telephone exchanges we can use, and broadcasting units we can use, right? Radio stations, TV stations we can use, electric trains we can use, mines we can use, laboratories, hospitals, automobiles, like automobile industry means what, electric cars, electric buses, etc. we can use, and also we can use in the power stations. Now we are observing this diagrammatical representation. With the pictorial representation we can understand that what are the applications of this particular lead acid storage battery here. Thank you. We are not just about providing quality education, we believe in all round development.